We'll now begin looking at extreme values. Basically, we're finding maximums and minimums mostly by using the derivative. Now, we define an absolute maximum value just by saying, it's the highest value, and absolute minimum that if you compare all the values in the interval given to you, it's definitely the lowest. The extreme value theorem tells us that anytime we have a closed interval, so we have to have closed endpoints, then we're guaranteed to have a maximum and a minimum value. This could happen because we're going up and down and we choose a maximum and a minimum. We can compare everything. It might be our endpoints that we're checking, where we have the maximum minimum. One of the minimum might be an endpoint, maybe the maximum's somewhere in the interior, or kind of the other way around. And one thing to pay attention to here is it does say a closed interval, and this is important because if I had open intervals, I'm not necessarily guaranteed, like in this one, there is no maximum because we don't have a definite closed point on there. Now, we can have different kinds of extreme values. We could have an absolute maximum, which would be definitely the highest for the whole interval, an absolute minimum, which is definitely the lowest for the whole interval. But we can also have what are called local maximums and minimums, where if we just take a region near it, so we can kind of just take an open interval around it, and we can see that's definitely the highest for that interval. And it doesn't matter how close you get, but that we can definitely say this is the lowest for anything around it going both left and right from that. Local extreme values then would be when we're looking inside the interval and we're looking basically in a neighborhood of that. It says for all x in some open interval containing c. So we kind of choose that open interval based on just getting really close. It's kind of like thinking about a limit. I might have to be really close to that to actually see it. You know, maybe if I go from here to here, this would be my maximum or minimum, but I could get closer around any of these points to zoom in and say, well, around here, that's definitely a minimum. Around here, that's definitely a maximum. Now, the calculus way of finding extreme values is not to plug it into our calculator, and you won't get any credit on tests if you just do it the old-fashioned way of graphing the function and figuring out where your extreme values are. Instead, we're going to use this by using the derivative, which is going to guarantee that we're not missing any really small ones. And so there's two places where this will happen. One is going to be looking where f prime is equal to 0. Now, that's if the derivative exists. It could be a local extreme value. But it could also happen at a place where f prime does not exist. So really there's 2 points. Now we call these critical points any point where f prime equals 0 or does not exist. Okay, so if we want to find extrema, we're going to check the y values at critical points, so where f prime is equal to 0 or does not exist. Now remember also when you check these that just getting a 0 does not guarantee that you have a maximum or minimum. For example, with this one, we might have a 0 tangent line. It doesn't really change direction here. And the same thing on the other one, I might be approaching a vertical tangent, or I have a cusp or something where this just doesn't agree on both sides. And so this would not exist. However, neither one of these is giving me a maximum or a minimum. What we should actually check for is go ahead and check your y values, check a y value to the left and to the right, and see if this is indeed, check the y value at that point, and check if this is indeed a maximum or a minimum, comparing it to the points around it. We shouldn't forget to check endpoints if it's a closed interval. Now sometimes the question will ask where are the extreme values, which means they just want you to answer with the x values. And other times they ask what are the extreme values, which means they probably want the y value, but you should probably give the x value also. Sometimes they'll directly ask for a point, so just give the xy answer. In this example here, we're asked to find the absolute maximum and minimum values on this interval. So we have our function. We would start by taking that derivative, and notice that in that derivative, this will never be equal to 0. However, we do have an x in the denominator, so it's undefined at x equals 0. That means f prime is undefined at x equals 0. So this is one of our critical points. And so we should check the f value. The original function is what we're checking there. Find the y value at that point. We should also remember to check the endpoints. So my endpoints of my interval would be -1 and 2. and so I'm getting the values of 3 and 4.762. So I have 3 possible values to choose from for my maximums and minimums. We were only asked to find the absolute maximum and minimum, and so I would be looking at 0 and 4.762. And so we could say the absolute maximum value is 4.762 and occurs at x equals 2. Absolute minimum value is 0 and occurs at x equals 0. In this next problem, we're looking at this function here. And before we start, we should be careful. They haven't given us a domain or an interval to work with, but the function itself gives us an interval that we need to look at. So if we consider this domain of this function, it's only an open interval from -3 to 3. Okay, so we don't have any endpoints on this because this is in the denominator where we're getting the zeros. So our next step would be to take the derivative, and I won't show all the steps of that. You would use, once we have the derivative, we want to find the critical points. So remember, the first thing we do is we set the derivative equal to 0, which is going to happen when x is equal to 0, looking at the numerator. If we look at the denominator, we're also going to find the points where f prime does not exist by looking at the denominator. Now notice the solutions I would be getting for that would be -3 and 3, which are not in my domain anyway. So really, the only critical point that I'm getting is x equals 0. So looking at that, I would go back and plug that into my original function. So I've got f of 0, which is going to give me 1 over 3. This is my only extreme value. Now we consider then, is that a maximum or a minimum? If we plug in values around this, we'll notice that it's getting smaller before that, going down before that, going up after that. So we would check that by checking other values nearby, like maybe f of -1 and f of 1. We don't have to be too close because we know this is the only possible change, but we do have to be within our domain. And so I can determine that this point, 1/3 is a minimum. It's the absolute minimum is 1/3 at x equals 0. We should also note that there is no maximum. In our last example, we have been given a graph here, but we're looking at a piecewise function. So when we look for the extreme values of this, we do need to consider this point x equals 1 as a possible critical point. So when we look at the first one, we see that our domain is all real numbers. And for our derivative then, we are going to look at both of these values, which is going to give us a -4x and 1. Now notice I did not bring this or equal to sign down yet because I'm not sure yet. And we really should check our f prime, like assuming if I did plug 1 into here, notice that as I'm approaching that from this side, it's approaching a value of -4, where the other side is approaching 1. So we can see that f prime at 1 does not exist. If it did exist, then these two values would need to agree with each other. Now we can note, looking back at the original, if we did plug 1 into those, we would end up with 3 and 3. So the function is continuous at that point, and we have a value at f of 1 being equal to 3. So that's one of my critical points there where it does not exist. We should also check for the zeros. Now this 1 will never be equal to 0, but we can set -4x equal to 0. This will give us another value at x equals 0 as one of our critical points. So we should also check f of 0, which will give us, notice which part of the domain we're in, and that also agrees with where our derivative is. We're looking at x less than 0, so we do need to check, make sure we're in the right part there. And so that will give me a value of 5. So I have, when I need to evaluate whether it's a maximum or minimum, I should go back and consider my graph. At least that's what we're going to be doing for now. We'll find better ways of doing that later. But right now, I can see that this 1 from my graph, everything is increasing after that and was coming down to that point. So my f of 1 at x equals 1 is a local minimum. And my f at 0, we look up here, we see from our graph, it was increasing before, going down after. So x equals 0 is a local maximum. We can also see from our graph, since this is increasing on this side, it's going down on this side, there is no absolute extrema.